All right, so we were in the middle of doing our exam 3 review, and I plan on going over that. Let me go ahead and downloads. Right, we have our exam 3 practice. I'll open that up, but we are also going to go to Canvas. Right? Canvas. So that we can go over the turn-in procedures for the final project. Now, while that's loading up, first let me say that I'm not a jerk about this. If you mess up the turn-in procedure, you will receive a temporary, emphasis on temporary, but very scary 0, because that is the quickest way to communicate to a student who has not been here, right? If a student doesn't know what's going on or whatnot, just simply giving them a 0 is a way to kind of metaphorically slap you across the face to get your attention. Yes, that's not very nice, I know, but the point is that I need you to get it fixed as soon as possible, because here's my timeline. Monday, I deal with the barrage of last-minute emails, okay? Tuesday, I then proceed to spend that entire day watching the videos, which I'll get into, of you showing me your final project, right? You show me your final project, your last, you show me a video because I can't have you demoing it one-on-one. But now normally I have a lot more students to watch, so I doubt this will take the whole day. But I need to get it done as soon as possible because your final exam is next Thursday. So I need to notify students who got the best exam as soon as possible. A score of 1, generally what I do, because I used to have to very carefully email every single student who was exempt. Now what I do is I just simply mark the students who are exempt at 100, and then if you were in the running, you probably end up with a 99, and so if you see a 99, you might, until you receive an email saying everybody has been notified, you might still be in the running for that, okay? But 99s are often used to say, I was deciding between that one and another one. Feel free to post about your project on Discord to show it off if you want to. You might look at some people's projects and go, how in the world did they do all of that? Am I that far behind in class? Do I not know what to... No, some people started their projects, basically at the beginning, and it's kind of been a passion thing. Other students already came in knowing a whole lot, right? So the only thing you should ever measure your progress against in this course is where you were at the beginning of the semester and where you are now. Because this domain is look, in math, pretty much everybody goes in not knowing how this was done, maybe with the exception of 1 or 2 students, right? Whereas in this class, we have students coming in with a wide variety of experience. Even in other programming languages, knowing another programming language is extremely helpful and gives you the ability to really work and do things. So if you get a 0 on your final project, know not that all not is lost. There are 2 reasons. You will receive a temporary 0. These are not exclusive reasons. There might be others that I'm just not thinking of. I'm quite tired right now. Perhaps I should not have stayed up until midnight and beyond to try to get myself a Nintendo Switch 2. It was worth it though, so yay.
Wait.
What?
Wait, isn't the Nintendo Switch like $450?
Yes, it is $450, yes. You're not that height, but my kid is. So priorities, yes.
Does that console have like a different cartridge system?
No, it does not. It does not actually have a different...
It has the same cartridge as the first one, so...
It's reverse compatible, has a higher horsepower. Don't compare it to the Switch. I would not compare it to the original Switch, other than in the format, but instead I would compare it to something more like the Steam Deck in terms of power. It's the difference in power and graphics processing power. you're getting me on a side here, but I need to say it. The thing with the Nintendo Switch, the original Nintendo Switch, what's really been holding it back in terms of being able to produce a lot, play a lot of games is the fact that it's running off of some now older hardware that wasn't already, and it wasn't already that strong to begin with because they were optimizing for weight, heat distribution. Nintendo knew its audience. If you compare the Nintendo Switch to a Steam Deck is massive and heavy. It's so much more comfortable to play with something like the Nintendo Switch. It's a great example of design and making choices for design because you know your audience. If your audience involves kids who are going to be playing it like a Game Boy, you want battery life and weight. Yes.
This is like an interjection, but if I'm correct on my hardware, I'm pretty sure that with the original Nintendo Switch, they got the same GPU that they had from what was called the Nvidia chip, which was like this console that came way, way, way back when I was like 3 years old.
I don't know. I don't remember. But with terms of the amount of CPU power, it's, again, also putting it into the, they limited the amount of output that CPU could have simply because of the amount, because, again, you're trying to manage heat, manage battery. This is something I can talk about later because I can go on about this kind of stuff. Anyway. All right. So anyway, 2 reasons why you might get a temporary 0. See, I was able to get back there myself. 2 reasons you might get a temporary 0 are 1, your GitHub repository is private. 1A or 1B, I should say. You didn't put your code on GitHub, which really you should have, so do that. So GitHub repository is private. GitHub. And really put it on GitHub because honestly, that's how, and here's the thing, if it's on GitHub, I'll be able to say, oh, it's not late because I can see the timestamps you put it in. 2, you didn't submit a video file or I couldn't find it, right? Sometimes I can't find the file and you put it in what you think was an obvious place, and it might have been an obvious place, but I did a dumb and couldn't find it. So that's why it's, again, temporary. And as soon as I get it fixed, I'll be able to, update your grade to what it is. Often I'll leave a comment saying why that is and if it's a good project, I'll say, fix this so you can get your A. I'm not going to be a jerk about this. All right, so now let's go to the modules and actually go to that assignment itself. Go in with how to turn this in. Final project, right? Submit a link to where your GitHub repo is hosted. While I only need 1 person in a group to submit it, it is more convenient to me if everybody in your group submits the same link. Or, failing that, just simply tell me, look at this group member for it. Because I might see an empty score and I might miss that you were a group member, and that will just have to get fixed, after the fact. But if you get a 0, but if you're part of a group, you get a 0, but your other group mate's got an A, just email me and tell me, hey, I think you missed me. And I'm like, oh, yeah, I guess I did. Sorry. And that'll be fixed. A lot of these things are fixable, yes.
If we use like outside resources, should we cite them on?
Oh, that's awesome if you do. Yeah, I would like that very much. Citations we're not looking for specific format. Just giving me the URL and why it's relevant is great. You must submit a 1 to 2 minute video. Give me a second. I'm going to go and fix that because I never get those. 1 to 3 minute video. Save. Okay, 1 to 3 minute video detailing your project. This can be uploaded to Canvas, linked elsewhere. YouTube's always a great choice for that kind of stuff. Or as long as it's obvious and easiest for us to find. Putting your video link in a comment, awesome. Putting it in a README file in your GitHub repository, awesome. Just making it nice and easy for me to find. Giving it to me as a second submission also works. I'm smart. I'll be able to figure it out. Okay? I'd like to think I'm smart. I don't think I'm that smart. Darn. So let's see. Anyway, but as long as you give it to me, you'll be able to show it to me. I will go over how to record a video in just a second. It's really not something to worry about. Your video should be a walkthrough. It can be slides. It can be screenshots. It can be a voiceover. I once had students, when they made something physical, act out a scenario with their magic button that they hit to send out a broadcast Discord message to everybody. It was a real life kind of emergency meeting button from Among Us, essentially, except it sent it out via Discord. It was pretty funny. Involved a person playing dead, so good acting there. Include the URL to your video. Upload your video as public or on YouTube, or if you put it to you. Yeah, give me a second. Again, I'm sorry. If you upload your video to YouTube, upload it as public or unlisted. That way, because again, if it's private, I won't be able to see it. If you don't want random people stumbling across it on the internet, that's what unlisted is. Only people with the URL will be able to find it. Okay? Your video is not a walkthrough necessarily of your code. It's a walkthrough of your final product, if that makes sense. I don't need to look at your code unless your code is particularly interesting, right? What I'm looking for is like, this is what I made, right? And this is why it's cool. Again, if you're worried about the amount of time you have to fill, it's like 1 minute. You'd be surprised how quickly it goes through. It should be a general overview of your final project. Include anything else you want to say, such as difficulties you faced or overcame, the things you learned, enjoyed in README file, if you need more than that, right? I'm very interested in what challenges you encountered in coding and how you overcame them or went around them, or if they were a blocker for you, right? We understand it may not be possible to complete what you originally proposed. We're interested in how you responded in the face of adversity. We're interested in the journey, not the destination. If you made an honest effort, I will know that. Most of the grades I give are A's. I give a few B's out. And occasionally when it's like, I don't know if the student really tried, it's a C, because I give you the benefit of the doubt, generally. Okay. Guidelines for an A. It amuses me. I'm a very easily amused person. Amazes me. Makes a positive impact on the world, no matter how small. Very, very, very easy to amuse me or amaze me. I'm a very easily surprised and easily amazed person. Okay. So again, submit the link. It's two things you need: GitHub and your code on GitHub, so I can look at that, and your YouTube, and your video on YouTube or wherever you want to put it. Okay, so how do you make a video? So easiest way for you, believe it or not, is to boot up Zoom, okay, and just hit the record button and share your screen on Zoom and hit the record button. That's the easiest way, right? Let's go ahead and look. Let me go ahead and boot up Zoom for a second to look at that, okay? It's a quick and dirty way. It's not necessarily the most high resolution, but it works in a pinch, right? What you do is you hit new meeting, right? Everybody has, right? Assuming you've installed Zoom on your computer. This is just one way. I know that everybody kind of has access to this, right? I'll mute, start. And what you do is, and I'm just making sure that I've got, so here I am. Doesn't matter. I don't necessarily need to see your face, although it can be better. You hit share screen. You select the screen you want to share the entire screen, or if you want to share specific content, you just share that content. Be sure to review your video before you upload it, obviously. And then if we actually make this bigger, we'll see more buttons, right? This is the relevant button. You hit record, and you want to record it you probably want to record it to the computer, although you could upload it to the cloud and have Zoom handle it to you. That's one basic way to do it. Whenever I do a lecture over Zoom, that's how I do it. My preferred way to record is using OBS, which you can see right here. That's what's going on right here. OBS, if you watch anybody on Twitch or live stream on YouTube, right, this is what they're using. They're either using this or some derivative of this. Okay, it's open source. You can download it for any platform. And it worked there. It requires a bit of setup. You need to basically manually add what you want to have, but you can then drag it around however you please. This is going to be very confusing in the recording. You can drag my face wherever, right? And I can arrange that wherever it needs to be in the recording. So so this is going to be very interesting recording after the fact. You can see how long your video is here. There's hotkeys to start, and you can set up hotkeys to start and stop it. So yeah, and there's tons of different, and then I think there's a lot of apps. I think Mac has a native app these days. It may not. I don't use a Mac. Windows, I'm not sure if it has a native app. But again, there's a lot of solutions for that. Screen record is a classic one. Possibly the least impressive thing you can do, is take your phone and video capture your screen. Please do not do this. It is very unprofessional in this field. Just because it shows this person didn't even bother learning how to do a screen record. That's what it says. And also, like, it's hard to read any text or anything like that. It's just an unprofessional way of doing it. It leaves me unimpressed, shall we say.
No.
What?
I was literally thinking of doing that. Okay, I guess.
Yeah, I mean, also the least impressive demo I ever, or demo attempt I ever had involved somebody trying to do that to their screen. It was awful. And it's also the reason why I have that 2-week stipulation in my syllabus that I ignore a lot of the time, because it's so I can say no to that particular students or students who are doing that again, because it was awful. It was the worst. It was painful and awkward. All right. So anyway, upload it. Let's say it is 10:59 on Monday, and you are still trying to get stuff done. What should you do? Do you, A, email me for an extension, B, furiously code and try to turn it in late, or C, turn in what you have? C. The answer is C. The answer is C. The only reason you're going to get extension if you're in the hospital, or somebody else is in the hospital, and you didn't put them there. Right? But seriously, I don't really give extensions. If for some reason you're turning this in late, they're like, if you know, I just need 1 more minute, 2 more minutes, right? 1 more minute, 2 more minutes, I'm honestly not going to care. Beyond that, though, there is a stipulated late penalty in the syllabus. It is 1/10 of a point per minute late. 1/10 of a point per minute, meaning a whole hour we'll dock you 6 points. Okay, so I had a issue a couple of semesters ago where I had a student who was very irate that I gave him such a low score on his final project, somewhere around 50 or 60. This is because he lost like 24 points or it was some large amount of points because it was turned in at like 4 or 5 a.m. But it's in the syllabus. Turn in what you have. Talk about why you couldn't get there. Be honest with me. Honesty is very appreciated by me on these things. I understand that sometimes that it's been a crazy semester. Okay? Let's see. So that should about cover any questions about turning this in? Yes.
Kind of a bit of a question.
And then I see you. Yes, as well. Yes, what's your question?
How do you basically do a screen record when your game is like mostly at most the size of a phone screen?
Oh, excellent question. You can always just, first off, if it's on your screen, that's great, whatever. It's if it's a small thing on your screen, whatever. Okay, because if the nature of the app says it should be that way, whatever. Two, you can always, if you're using Zoom to screen share, or in fact, if you're using OBS as well, you can select a specific thing you want to record. Okay? You can say, or specific thing you want to share. When I do Zoom, you see that all the time. Rather than sharing your entire display, you can share a specific window. And then that will scale, on Zoom, that will scale to the size of your screen. So, and on OBS, right, I can show you. Whatever video source or capture you're adding, you can increase it or decrease it to whatever size you deem necessary. Okay? And that goes for like this as well. Like including this over here. Oh, I'm moving it right now, but let me come on. See? I can say this and now it looks very smaller and I'll have a bunch of black space there. But again, you can arrange these things however you want. Okay? So, and you had a question, yes?
If we just like for the instead of doing a voiceover and we just wrote all of the stuff in the description, would that be sufficient, or would you actually like it to be in the video?
I prefer voiceovers because here's what I do. I go through I basically speed run my way through the videos just to try to because that's going to show me, it shows me very clearly the ones that I think are in the top, and then I can use the descriptions afterwards to kind of tie break.
Yeah, so my issue is that I would require for my video to include music, so I'm not sure if I would do voiceover.
You can always say what you need to first, and then you can run the music. Or you can always say in the description, see here, you can just let me know, okay? Especially since it's a music-related thing. Okay. Other questions about that? The goal is to let you know, again, the reason why it's due Monday is so that A, it's the last day I can make stuff due. B, I want to make sure that on Tuesday I can go through every single one of these and inform every student who's exempt from the final that they're exempt from the final so they don't have to waste their time studying on Wednesday, right? I'll just waste your time on Tuesday because you're going to be studying on Tuesday, right? You're not going to be wasting time you're not going to be wasting a study day. My advice, I may have said this before, but my advice for studying, if you have an exam on Wednesday, just in general on any Wednesday, if you have some kind of exam or assessment on Wednesday, I always find it advantageous to have your studying done by the Monday before, because inevitably something is going to go wrong on Tuesday, or possibly very right on Tuesday, right? Something could go wrong on Tuesday that requires all of your attention and leaving no time to study. Or somebody suddenly tells you, hey, we want to do this cool, awesome thing on Tuesday. And you don't want to say no to that cool, awesome thing and miss out because that makes you feel terrible. But it turns out if you finish all your stuff on Monday, then that Tuesday's free. This also comes from take that with a grain of salt. This comes from a person who cannot study the day of the exam. It just does not work for them. This is me. I don't know why I'm suddenly referring to myself in the third person. Okay. Okay, yeah, so I find that works out because Murphy has it out for me. He of Murphy's Law. So exam 3 will be tomorrow and on Monday, depending on when you took it. Sorry, when your lab is. So you'll need to take it then. On Thursday, you'll have your final. So I'm sorry for giving you multiple assessments back to back, but again, this will replace your lowest. So if you're going in to this, you know that basically your score can't get any worse, right? This exam can only help your score, exam 3.
Wait, exam 3?
Yeah. Exam 3 can only help your score. The one you take on Friday or on Monday, it can only help your score because we dropped the lowest two. So worst case scenario, you do terrible on this one and your score doesn't change. On the other hand, you do better, your score goes up. Yes?
Has exam 2 been graded yet?
It should be. Have they not? Okay. You also should have gotten a big swamp of notifications because I uploaded the thing. I mean, if you're having an issue with getting your exam, yell at me so I can yell at the TAs. I plan on grading exam 3 as quickly as possible, but you should have a good idea. I plan on also finishing the review of the questions that I said I'd leave off over here. Final exam, I will send out the day. It will be in here. It's May 1st. I'll send out the time for it, but again, you go to the table. I announced it in previous sessions. Now, I mean, let's go ahead and look it up one more time. Final exam. Boom. Our classes are, it's from 2 to 3:20. 2 to 3:20, Thursday, 5-1, 1 to 3. So if you come in here at your normal exam time, well, you've kind of rolled yourself into hard mode, haven't you? I will be sending this out as an announcement, but it will be on Thursday. Remember, if there is a event that prevents you from taking the final for some reason, again, you're in the hospital or something, email me as soon as possible, right? Emphasis as possible. Because obviously if you're unconscious, you can't email me. But in those cases, typically what has to happen is that I have to, is that it needs to be an incomplete. Those are a pain because that requires coordinating with somebody, and that's actually sometimes surprisingly hard. So 1 to 3 o'clock. You are allowed a cheat sheet as normal, right? Front and back. I don't care about the size so long as it doesn't interfere with the student next to you. Okay? Or any student, but you get the drift. Remember, if you have more than 3 exams in one day, don't. You're allowed to email and say that, no, that this is an issue. Okay? You had a question? Yes. It'll be in here. Fortunately, most of the labs are either here or very close to here, so if you make that mistake, I will email with all the details. I just want to make sure you've got that. And then finally, we need to go over again what questions we have on our exam. Okay? View, change color scheme. We'll go default and see how well that works for everybody. I think that actually works pretty well. Okay, so questions. Exam is of the following format. 7 questions. Choose 5. Each is worth 20 points. Each has a rubric assigned to it that will help, that also acts as a guide. The last question is the mystery question, as I said. This is the only question where you don't really get any kind of information about it, okay? This question basically says, here's something built into Python. Here's the documentation on how to use it. Here's the situation, and then I give you a problem, which is kind of meant for this thing to be used in. Solve the problem. It's not as hard as it seems. Okay, next one. We have loop with modular arithmetic, modular arithmetic. Okay. Then we have our Monte Carlo question. Kind of going in reverse order or something resembling the reverse order for this exam. Your Monte Carlo question is fairly straightforward in terms of the rules, although it is one of the longer problems that you would have to work on. Not necessarily hard, just a bit longer. Okay? It's a good one. Then we've got, let's see, list of lists problem, file reading. We have our turtles. The angles that I might use angles of 30, 60, 45, and 90, right? These aren't particularly bad angles, right? Either a third, 2/3, a half. So basically 2/3 of a 90-degree turn, 1/3 of a 90-degree turn, half a 90-degree turn, and a 90-degree turn, right? These allow me to do some shapes that are actually pretty good. Oh, and 180 if I need to turn around, but that hopefully you know how to go the other way. But it is, given this code, draw this thing. One strategy I might recommend, by the way, is if you're having trouble or want to confirm that the angle is correct, it's often easier to understand things. First off, it's a bit difficult to get up in class and kind of move around and drive yourself as the turtle. But doing something like, taking your paper, okay, and then turning your paper, right? Your turtle needs to go to the right, so you turn the paper to the left. Doing that might help you keep the angles to the size that you need it to be, okay? So that's just one strategy in case if you find yourself getting confused. And don't worry about I give you plenty of space because I expect you might need space. Not because it's a very big thing, but because you might have a lot of scratching out of stuff. Give you a lot of blank space on this exam specifically for that reason. Okay? And then finally, regex. Okay? So the regex replacer, like exam 3. Okay? Yes?
Regex isn't covered in the textbook at all, is it?
It's covered in a secondary textbook I have linked in the syllabus, which is this textbook. Automate the boring stuff. Automate the boring stuff. And this is free, so you can access it for free. It is under Chapter 7, Pattern Matching with Regular Expressions. Lots of RoboCop examples. So it goes over here. It's also, regex is something that takes about 2 hours worth of time to kind of really get a handle on regex, and maybe 1 hour to just get a handle on how it uses on Python. But those 2 hours will pay dividends in future endeavors. Okay? That's why I try to emphasize it. So those are your 1, 2, 3, 4, 5, 6, 7. Okay? Again, choose 5. Now, to prevent against metagaming, because I think like a metagamer a lot, it is, or I think about the rules and ways to exploit the rules is what I'm saying. If you answer more than 5, I have the caveat written on top of the exam. If you answer more than 5 questions, I'm not going to play the game of what is most beneficial to you. I am just simply going to answer the first 5. I'm just going to simply take your first 5 answers. Okay? If you do attempt all the problems, though, that doesn't say don't attempt all the problems. The other thing you can do if you do attempt all problems is just simply write, grade this one, or don't grade this, because there's plenty of time to answer all the questions. So, I only need you to answer your 5 and then you can walk out. But if you want to attempt, you might find, okay, I've done my 5. I'm not sure about this one. I have some time left. Why don't I go ahead and try this one, right? That can be a good test-taking strategy. And then if it ends up being a pile, just simply, write in big letters, don't grade. It's very, I'll get the idea. Similarly, any assumptions or something that you need, you should write that on the exam. Let's go ahead and say you forget another thing. Let's say go ahead and say you're writing something and you've got a line, right, in your file reading program, and the line, you know this line, right? It's numbers and they're separated by commas, right? Okay? And you forget how to call line dot split to separate them up, right? Let's just say you're blanking on the test because you're panicking, and when the brain panics, it does weird things, okay? Like forget entire words, even though you know the concept. Let's say you forget that. You can always write, you need to separate it. So I will totally understand something like this. Line dot some function, magic function that splits or separates them by commas or something, right? You get the drift, right? And maybe you add LOL, can't remember, mercy please. Right. But the point being is that, in this kind of situation, in this context, depending on how big of a magic hand wave that is, will impact how much of a penalty that is, right? This case, this is probably a 1-point penalty because you just forgot the word split, right? On the other hand, if it's something like we're doing the exam 3 review, right? And I gave you, let's assume for sake of argument, I don't give you this, that takes a line and turns it into a list of integers, right? Normally this requires like 4 or 5 lines on your effort to do. If you write magic function that turns lines into ints, right, over here, and you're very clear about what it does, but you don't know how to write it or whatnot, that might be a separate penalty, right? It all depends on the rubric based on context and stuff. But if you get stuck on something, you can always make it a magic function and then try to define that magic function later, right? The advantage of problem solving in programming is that you can abstract things away. You can turn problems you don't know how to solve into functions, assume they'll work, and then come back to that and try to solve that function, right? And as long as you communicate with me on paper that is what you're trying to do, it's going to be a lot easier for me to grade that, or the TA to grade that, okay? Okay, so don't be afraid to do things that you can't normally do on this, because again, it's an exam. And honestly, it's much more impressive to see your problem solving like that than to just see a bunch of panic scribbling. The one thing you don't want to do is, hey, I have a bunch of code on this is a file reading problem. So I'm going to take the file reading problem from the practice exam and basically copy paste it into the exam itself. That generally I generally have a low opinion of that, because it's like you're taking code from one context and it generally, even though it's the same kind of problem, you're not adapting it. Like, okay, you're taking the problem that adds up all the numbers as opposed to, but on the exam, I'm looking for, give me the biggest word per line. The code that adds up all the numbers doesn't really match up here in the same way, right? So generally that the worst, and that tells me, oh, this student doesn't really know what's going on. Or similarly, the Monte Carlo problem over here will revolve off of rolling a die, okay? But if you give me an answer, and if you go to your cheat sheet and give me a Monte Carlo problem that we've done before that involves either cards or coin flips, I'm going to be like, yeah, the student doesn't know what they're doing, right? You're just applying things and hoping it works. Okay, so with that, let's go ahead and solve the remaining problems on the practice exam. Okay. Exam 3. We were working on this problem that on the practice exam. The practice exam basically had this problem that I said was hard, and I was running out of time to do these because I wanted to go into plenty of detail about these. I went into detail how my magic function works, and you don't need to know that, but I can't, you know, I'm given an opportunity to teach, and I take it. It's why I like it. It's why I'm here. All right. So what we're trying to do to refresh you in this problem is that we are given a file composed of lines of positive integers, right? Positive integers is just the mathy way of saying the normal non-negative numbers that we use, okay? And we want to return the sum of all the numbers that are adjacent to their square roots. So 25 is adjacent to 5. 5 is the square root of 25. So we're going to add 25 to our running sum. Similarly, 4 is adjacent to 2. So we're going to add that as well. 76 is, I have no idea what the square root of that is, but it's not adjacent to that. Same with 12. But 36 and 6, 1, 1, 1, 1, right? So technically, we're only going to be adding perfect squares. In other words, square numbers that are basically, you know, nice and clean, like 36, but not like 30, because 30 is not a perfect square. You can't square an integer to get that. Okay? And what we worked on Tuesday was I gave you this magic line thing that turned a string that looked like this, right, which is a line you might read in the file, into a list of numbers. So each of these is automatically, so we split it up into a list of strings and then took that string and converted every string in it into an integer. But I already wrote this, right? This was part of the exam, just simply so to make it a slightly easier to use, right? So, and then what we said is that we're going to tackle this based off of the rubric, where part of the rubric is we need to, you know, add up all these numbers but only the numbers that we're supposed to. But other parts of the rubric involve just if we simply add up all the numbers, we can figure out the other part later. So over here here's our data. We read all the lines. We create a running sum. For every line, we transform that line into a list of numbers. Then for each one of those numbers that came from the line, we add that to our total. Make sense? So here we are not filtering out any of the numbers. We are literally going through and adding them all. And according to the rubric, which I put down, because this would be 10 points out of 20. So now let's look at the other ones. Identifying which numbers are adjacent to their square root. Okay? And it's the second one so this first part isn't actually the really hard part. This is actually not too bad to do. But ensuring that there's no out of bounds, that's the tricky part. That's why it's a separate 5-point thing. So rather than adding the numbers, we kind of need an if statement in this over here in order to say, is this a number we want to add? Now, a couple things we need to consider, right? We might have to scratch this out, or parts of this out, if we're writing this down, because we need to modify this for loop. When we're talking about numbers and having to look at adjacent numbers, right? When we do that, we care about the index, right? We have to worry about what index we're working with. You always have to worry about the index if you are looking at, okay, I have to look at the number before me or after me. In this case, we have to do both because we're adjacent. There's a couple different ways to do this. The first way is to say for index in range. To iterate over the index, we say for index in range. And in this case, it would be length of nums, right? Length, to go over the indexes of the thing, of something, you say for index in range and the length of the thing you want to iterate over. So say you have a list of 10 numbers, right? This will go over the indexes 0 up to and including 9. Up to but not including 10, right? Because a list of size 10 will have indexes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Go up to but not include 10. 0 and plus 1 through 9 is 10 total items. So, okay. The other way to do that is to do, so you could do this to get the index. One thing I really like to do, because you can do this in Python, is for index, comma, n in range, sorry, not range, but enumerate nums. That's a big word to remember, and it's kind of a special Python thing, which is why I kind of only say, hey, this exists, because I don't necessarily think you'll remember it. Let's go ahead and move that up. Let's see. So what we'll do is we will take that and put it there. But that's equivalent to me doing these following lines. N is equal to nums of index, right? Okay, so you just simply have a way to iterate over this now and go through it. Now, we need to check if we are adjacent to this, to a square root, okay? So the previous item is equal to nums index minus 1, right? That's index minus 1 kind of says the item to my left. Actually, let's call it left and right. To go to the left, right, if you think of this as a list of numbers, right, left to right, the item to your left is index minus 1. That's adjacent to you on the left. And the number to your right is nums index plus 1. Make sense? Okay. So we have we get n, we get the number to the left, we get the number to the right. And so now what we have to do is check our numbers. Okay, and this is what makes this one, so this first part, not too bad. Just simply saying, okay, right, I have to remember how to check the numbers before me and after me. If I'm at index I need the number after me naturally would be I plus 1. Then the index before me would be at and the number after me would be at number before me would be at I minus 1. After me would be index I plus 1. So nums, left, right, if. So now you only want to add a number if it's adjacent to its square root. If n is equal to, we want to check if the number adjacent to us is our square root. So how do we figure out what the square root of n is? Square root, or specifically math dot square root. If you forgot the math part, then I wouldn't really hold it against you. But math dot square root of n is equal to left or math dot square root equal to square root of n is equal to right. In that case, we'll indent. So we only want to add it if the item to our left is equal to our square root or the item to our right is equal to our square root. Make sense? So this gives us would bring our total up to 15 points out of 20. Now the issue here is that if we're index 0, that's actually not a problem because it's a minor problem because it checks the index -1, which is the last item in the list. So, but more to the point, if we're on the last item and we try checking the item to the to the right of us, that's going to go out of bounds. So there's two ways we can go about this, which is, so we can recognize that there's only two places that we're going to have an exception, the beginning and the end. And we could carve out separate cases for them, right? We could do something like this over here. If index is greater than, if index is equal to 0, if index is greater than, is equal to len of nums minus 1, in other words, if it's the last index, right? Else do this, right? And then we would only check if we were index 1, we would basically copy paste and only do the right, and then we'd copy paste and only do the left. It would look something like this. So this is one way to do it. There's a lot of different ways to do this, right? If we're at 0, then we don't want to go to the left. So we would say we'd only care about the right. And if we were at the end, we wouldn't want to go to the right. We'd only care about the left. Make sense? Because you're only on those sides, because if you're on the end, you're only adjacent to one item. If you're at the beginning, you're only adjacent to the item to the right. If you're at the end, you're only adjacent to the element to your left. So this is one way to do that. Okay? Let's go ahead and copy this, paste it, think about another way to do that. Let's go ahead and see another way to do that. Okay? Said there's a lot of ways to do that. Okay, is there a way we can be a bit clever about this, I wonder? Let's see. I could set up nonsense values instead and say, like, if index equals 0, if index is not equal to, what I could do is I could set up left is equal to -1 and right is equal to -1. Why am I choosing -1? I could also choose 0, but no number that I would add would basically have a square root of -1 because we're dealing with integers, not complex numbers, right? We're not dealing with I values. It's a weird thing to be doing. Similarly, 0, right? If I'm adding zeros in, it doesn't matter, right? Right? The square root of 0 would be 0, but if I'm adding zeros, it doesn't really matter. So I could do -1, I could do 0. So I set up left and right. Why am I saying it doesn't matter? What does that come across as? What I can do now is I could say if index is equal to 0, if index is not equal to 0, that means I can safely check my left, right? And if it is 0, I'm just going to have a dummy value right here for it. Make sense? And similarly, if index if index is not equal to len of nums minus 1, as long as it's not the last index, that means I can check to the right. Right? So I have default values for left and right, and I can say if we're at the end, if we're not at the beginning, we can look at the left value, and if we're not at the end, we can look at the right value. Make sense? So that's another way to do this. Let's see one other thing. I want to check something really quickly for my other weird idea. Can we use slices here? And the answer is it depends on sum of. Okay, so the sum of an empty list is 0. Okay, So let's see. And what happens if, can I do something like this? Index is equal to 0, okay? So L is equal to 4 comma 4, right? 4, 3, comma 2, comma 1. Okay. L from beginning to index. What does that give me? Gives me empty list, right? From the beginning up to, but including index, or if I could say L of index minus 1 to index. Does this work? No. Oh, yeah, there we go. Index minus 1 up to, but not including index. What about L of index up to? What if index is equal to 2? Index, so I'm just trying to see if this works like I expect it to. And it does. So we could be clever with slices, okay? And the sum notation, and the sum operator to basically grab something. What do I mean? I could do something like, and let's grab it once more. We could potentially avoid if-else statements by being a smart aleck with slices, right? We could do this. And what we could do is we could do sum, right? Originally we had values like this. Num in the item to the left. So let's see. Index minus 1 to index. And then index minus 1, the value to the right would be, we'd want to include index plus 1, go up to, but not include index plus 2. Right? I believe. Yeah, it seems to work. Where you include the start, but don't include the end. Right? So if it's in bounds, this would work. If it's out of bounds, you're just going to get an empty list. And then you could sum that empty list. And if you get a single item, well, the sum of that item is, well, you're getting a slice. So this is returning a slice, which is a list. And the sum of a single of a unit list, a single item in a list, would be just the only item in the list. It required a bit of floor planning and understanding how Python worked, but it's a shorter way of doing it, in a way that relies off of those fact that slices are pretty amazing. Everybody follow that one? Okay, so there's plenty of ways to do that one. But again, because it required so much, right? You had to check, okay, it's out of bounds. You had to check if what the adjacent values were. That such a big deal that's why I mentioned that this one was hard. It was very involved. All right. So I believe I went over this one in class. Yes.
So with that hard question, what do you think is like a good amount of time to work on that? If we're stuck,
It's hard. It depends on your test-taking strategy. I'm always opportunistic, and I do what I consider the easiest questions first. And if I'm stuck on it, go back. So I would move on instead of handling. You need to be able to complete problems, because otherwise, if you feel like you're not completing problems, learned helplessness is going to take over and impede you from doing other problems.
So say if you did all the problems that we did, and we were stuck on that last
honestly, I don't know how long that one question would take because it was a hard one. I mean, it took me a while to explain it in multiple ways. So, I don't know. 10 minutes is generally a good place if you're not making any progress, then it's time to move on. And 10 minutes is a long time. All right. So over here we have a Monte Carlo problem. Want to play a game? If you win, you get $1, but if you lose, you pay $1. The game works like this. We take 7 black cards, 2 red cards, arrange them randomly in a 3x3 grid. You play by flipping over 3 cards in a line. It can be a row, a column, or a diagonal. If you flip 3 black cards in a row without flipping over any red cards, you win. Right? So this is the grid problem. Where we've got, it's one of those lottery games where you have to scratch off 3 symbols in a row. So, what are the odds we win this grid game where basically we flip over 3 cards in a row? This one's not too hard to set up. But again, what we need to do is we need to create, see what's our first, so let's look at our rubric though. Rubric 1, generate the 3x3 grid. Okay, let's go ahead and just create that as a separate function. Gen grid, right? We're going to need random for this, but we can assume that's imported. And I did import it earlier, but gen grid, right? What we're going to be dealing with here is, and this is actually probably the most involved part of it, which is generating this 3x3 grid of random cards. We have 7 black cards and 2 red cards. So cards is equal to black times 7, red times 2. Oh. All right. How much time do I have? A lot of time for this. Not enough time to change tack. Cards is equals. So now we've got, right. And then we need to concatenate these things together. So this gives us 7 red cards plus 7 black cards plus 2 red cards. Now we can use random.shuffle to take the cards and mix them up. And now we need to make a grid of them, right? If we want to be as accurate as possible. If you know your statistics, you can say, well, if I choose the first 3 cards all the time, I don't actually need to create a grid. I can just simply look at the 3 cards. But where's the fun in that? We're going to actually try to do this. So we are going to create our grid. Grid is equal to, and our first 3, we could do it manually, something like this, where you could say grid is equal to card 0. Our first row is card 0, card 1, cards 0, cards 1, cards 2, and we could just manually and say that is, and I could say this is a row, and then I could say we need to get the second row, right, and list it out manually. But again, knowing slices makes everything go much easier. I can say the first row is, we need 3 cards in our first row, so 0 up to, but not including 3, 0, 1, 2, comma. Then the next 3 cards would be, well, cards, and then our next row. So the first row is 0 to 3. The second one is 3 to 6. 3, index 3, up to, but not including 6, so 3, 4, 5. And then 6, 7, 8. 6, up to, but not including 9. Or I could just simply say it like this. Right? And that gets us our grid. Return grid. Okay. Now, let's see. what the next ones are. Let's actually read the rubric for what I suggest. Select your 3 cards, check if you win or lose. Okay? Simulate 10,000 games. So yeah, a game, what do I have to do for a game? I have to generate, so let's think about physically. What are the processes of setting up a game of this kind? The dealer takes his cards, he deals them out onto the table, and then the player picks their 3 cards. So really it's just 2 steps, or 3 steps. Generate the grid, which I broke up. Generate the grid, select the 3 cards, check if that's a win. So 3 steps. So those 3 steps physically match up to what we're doing computationally. So game. Step 1. Grid is equal to gen grid. There's no reason why we had to put it into a separate function, but it just felt right to me to do that as its own thing. Next thing is I have to choose my 3 cards. I could do that as my own function, but we don't need to. Now, we could just simply say grid, choice is equal to grid 0. Right? That's what we selected. The first row is our 3 coins. But let's say we want to be a bit more adventurous and maybe choose the first column. Or no. I want to choose the diagonal. Okay? That might actually be the worst possible strategy, just choosing the diagonal. But it feels fun, right? And this is a gambling game. Gambling's fun, right? You don't lose money when gambling. That's absurd. So if we wanted to grab that, then a diagonal is actually pretty easy. It would be we could do something like, hey, we want the top left, which is row 0, column 0. We could do the middle one, which is row 1, column 1. And then we could do the bottom right corner, row 2, column 2. We could do something like that. Nothing stopping us from doing choice grid 0. Or choice, probably as reasonable as doing that is grid is doing something similar, except going diagonals, we're going with a column. Grid 0, 0, comma, so this is all on the same column, so row 1, column 0, row 2, column 0. And if you're having trouble following along with that, draw it out, okay? But I'm not dealing with the grid here. Now, exam 3, the Monte Carlo question is, I mentioned a card game question. I give you most of a function where I set up the deck of cards. It still needs to be shuffled, but you shuffle the deck of cards same way you did here, right? You shuffle it. And then that one involves making piles of cards, but that's not too hard. But that one's a card game, and it's checking basically, hey, do we have these, nice, did you select the right cards? Next problem on the exam, again, is a dice game made for toddlers. And let me be clear on this one. The dice doesn't have numbers because these kids may not know numbers yet, but they probably know colors. And so the dice is actually a special dice with colors. So how do you deal with that? Remember, you can always make up, if I had a bunch of black cards and red cards, and I wanted to select one of those at random, what function could I use to just choose something at random from a selection of things? Random.choice. Random.choice is what we can use. We can also randomly generate an index, but random.choice is built into Python. It's very useful. So rolling a dice, you can simply set up, if it's numeric, you just simply choose a random number, or you could just simply label all the sides that you have and do random.choice. Okay. So anyway, here's whatever. Our choice is here for this one. We've got our grid. we've made our selection of 3 cards. That's another 4 points. Check to see if that's a win or lose. So how do we know if we lost? If we flipped over a red card, right? The kind of, there's 2 ways to do this, the long way and the Pythonic way. The long way is basically saying, wait a second, choice 0 equals, if the first card in our choice was a red card, or the second choice was a red card, so on and so forth. You see how that one goes? Or the third one is a red card. Choice 2 was a red card. If any of those was a red card, return false because we lost. We don't want to flip over a red card, right? Otherwise, return true. There's other ways to do this, though. Right? The Pythonic way to do that is we can ask, actually, before,
Choice have to do like what's on the board.
that's the cards that I chose from the grid. Those are my 3 cards I chose from the grid. So another thing I could do is, rather than writing this if statement, is I could write the more Pythonic if statement, which is, gosh, my fingers are just so mash on the wrong key today. We could do something like this. If red in choice. If we have a red, so the in function, the in operator is a wonderful function. It makes things a lot quicker. If you have a list of stuff or a string, you can check, hey, is this in that? And if it's in it, return false. Otherwise, return true. We can actually simplify this even further by just simply returning a Boolean statement directly. We could do something along the lines, so these are all equivalent. We could say return R not in choice. Because if red is not in choice, that evaluates, if we don't have a red card in there, R not in choice will evaluate to true. Otherwise, it will evaluate to false. And we can just return that directly. Yes?
So is it an operator or a function?
In operator, sorry. Operator. Function's technically a verb. We treat it as an operator because it's the subset operator. It's basically a subset query in terms of in terms of sets. We're asking if something is a member of something. So it's an operator. And if it was a function, we'd have parentheses. Just a bit tripped up by my language. All right, so now we need to do what? We need to simulate 10,000 games. So trials. Is equal to 10,000 for in trials. And yes, there's a bit that I just skipped, but range trials. If, sorry, and then we could just simply do game, and technically that would be running 100,000 games, right? But if we want to check the statistics, we need to check how often we're winning. Wins is equal to 0. If game equals true, so if we got true from the game, that means we won, so we can count that as a win. Wins plus equals 0 plus equals 1. Add to our number of wins. And then to print out the percentage of times we win, we could do, all we have to do is wins divided by trials. And this will give us a value between 0 and 1. Okay, 87. Go ahead, fix that on 87. Completely unrelated thing, but I know what it is. It is these two suckers. Okay, was never closed on line 152. Okay, 152. Oh. Okay. Yeah, I can see that's never closed. Whoops. Except we don't want that there. Yeah. Cards. Told you I'm tired. And then, what are you saying? Yeah, there we go. Oh, did not import random, I guess. Thought I did earlier in the file, but guess not. Okay. And the chance of winning is and the chance of winning is 42% approximately. All right. The other function I've asked, and this is there's another function. Once you can find it in some of the previous lectures, but one of the, like from another semester, I've done a Monte Carlo the board game that I'm doing on the final exam hasn't always been the question I've done. Occasionally I've done a Dungeons and Dragons simulation. How often does a first level fighter one-hit kill a goblin in the 5th edition of Dungeons and Dragons? So that one is a fun simulation. The answer is about more than half the time, believe it or not. So doing Monte Carlo and anything that involves chance is a good practice for it. All right, and with that, I have done pretty much everything. So